So probability is a really difficult topic, believe it or not, and we don't want to go into those complex issues now. We're going to keep this fairly straightforward with just these basic probabilities. Now, there are some conditional probabilities, but the key for us will be the notation and how to compute these. So, of course, what we could do is we can make a large um, tree chart and show all the different possible outcomes. So for this situation, we have a bag full of 9 balls, and we're drawing 2. So what I could do is draw a tree of the possible outcomes for the first ball. So that would be red, red, green, 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 yellow, 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 yellow. And then for the second ball, the 8 remaining, because it says without replacement, so I'm not putting the ball back in. That's one way to do it, but here, if you think about it, if there are 8 possibilities from each of the original 9, that's a grand total of 72 possibilities, which is a lot of writing to do. So instead, what we can do is we can make what's called a probability tree, where if we know the first ball is going to be either red, green, or yellow, we can write the probability right next to it. So instead of me writing out 2 reds and 3 greens and 4 yellows, I can say, well, the probability of me picking red at first is going to be 2 out of 9. The probability of me picking a green next is 3 out of 9. And the probability of me picking a yellow for the first ball is 4 out of 9. Now for each of these, again, I'm going to have 3 possibilities. So if I pick red first, I could pick a red, I could pick a green, I could pick a yellow next. However, now instead of there being 9 balls, there are 8 balls left. And if I pick red first, there's 1 fewer red, or 1 less red, so that's 1 out of 8 probability. But there's still a 3 out of 8 probability I get green, and a 4 out of 8 probability that I get yellow. Make that look a little bit nicer. Now all of these should add up to 1, and it's true that 1/8 plus 3/8 plus 4/8 equal 8/8, which is 1. Now what if I pick green first? Well, again, I could still have a red, a green, or a yellow second. So the probability that I pick a red is 2 over 8. Probability I pick a green, again, there were originally 3, but if I remove 1, there's now 2, and 8 total. And yellow is at 4 over 8. And finally, if I pick a yellow first, I could pick a red second, which again would be 2 out of 8 probability. I could pick a green second, which would be a 3 out of 8 probability. And finally, I could pick another yellow, which would be 3 out of 8. Here, this shows me all my 72 possible outcomes. If you think about it, each of these little subgroups is 24, right? There are 24 possibilities here, 24 possibilities here, 24 possibilities here. So there's 24 outcomes when red is first, 24 outcomes when green is first, and 24 outcomes when yellow is first. So that gives me 72 total outcomes. Now I'm actually going to copy this, and we're going to repeat this, use this over and over again. And we're going to break these down one by one. So first off, let's look at A. So problem A says that we want to find the probability of red and green. So this is the probability I get a red ball and a green ball. Now it's important to note here that order does not matter. So if I get a red first and a green second, that's the same as getting a green first and a red second, because this does not specify order, it just says and. So I'm going to be looking for a red-green and also a green-red. Now what I highlighted are just those 2 combinations. So actually, what I'm going to say is that the probability of red and green, I want to have the probability of red-green plus green-red. In order to calculate those, what I actually need to do is I need to multiply the respective probabilities. So the probability of getting red-green, that's going to be 2/9 times 3/8. And the probability of getting green-red, that's going to be 3/9 plus 2/8. Here, I get 6/72. If I add that to this, which is also 6/72, I end up getting 12/72, which I reduce to 1/6. So the probability that I get a green ball and a red ball is 1 out of 6. And again, because the order does not matter, I have to find both red-green and green-red and add them together. We'll see later a problem where the order does matter. But what the key takeaway for this is that we have to multiply these respective probabilities to get the overall probability. And then once I find those individual pieces, I add them together. So let's try this one out. This is probability of this is a probability of the a green and a yellow. So again, I'm going to highlight, make the best of this. And so if I have a green and a yellow, that's this. But don't forget, it doesn't specify the order. So I could also have yellow-green, and that technically is the same. So to find the probability of green-yellow, I do 3/9 times 4/8. And I'm going to add that to the probability of yellow-green. And that's going to be 4/9 times 3/8. Well, here I get 12/72 plus another 12/72 is going to give me 24/72, which reduces to 1/3. So the probability that I get a green and a yellow ball in no particular order is 1 out of 3. Now, if it said, what's the probability that I get a green ball first and a yellow ball second? Notice that's 12/72. And here I have that ordered situation. So again, I have the probability that I have a yellow first and a green second. So even though we could have a green-yellow, it's the same colors, but green comes first. And I don't want that. I only want the probability that I have a yellow first and a green second. So I just have to multiply these two probabilities. So I get 4/9 times 3/8, which is 12/72. I can reduce that to 1/6. So the probability that I get a yellow first and a green second is 1/6, whereas the probability I get a green and a yellow in any particular order is double that. Okay, now here we want to look at the situation where we have two colors that are the same or two colors that are different. So if we want to find the probability that we have two of the same colors, well, that's going to be red, red. That's going to be green, green. And that's going to be yellow, yellow. I lost my Y down there. It's a sad day. Anyway, so the probability that I have two of the same, so probability that I have the same, that's going to equal the probability of red and red plus the probability of green and green plus the probability of yellow and yellow. Well, the probability of red and red, that's going to be 2/9 times 1/8 plus the probability of green and green, which is 3/9 times 2/8 plus the probability of yellow and yellow, which would be 4/9 times 3/8. Now, if I compute these, I don't worry about reducing my fractions because I can do that at the end. So I'm going to get 2 over 72, I don't need those parentheses anymore, plus 6 over 72, plus 12 over 72. This adds up to 20 over 72, which I can reduce to 5 over 12. And that's the answer for D. There's a 5 out of 12 probability that I get 2 of the same colors. Now for E, better. For E, we could find the respective probabilities of different colors. However, think about it. We're looking for red-green, red-yellow, green-red, green-yellow, and yellow-red, yellow-green. We're looking for the remaining probabilities. Well, all probability adds up to 1. So if we do 1 minus 5/12, sorry, this is not 5/12, this is 5/18. 5/18. Sorry about that. If I do 1 minus 5/18, I'm left with 13/18. So the probability that I get 2 different colors is 13/18. I can make it as simple as just subtracting it from 1. Again, because there are only 2 possible outcomes. I either have 2 of the same colors or 2 different colors. Therefore, those 2 possibilities must add up to 1. Even for all of these, I have 3 possibilities of a ball. Red, green, yellow, whether it's the first time or the second time, and all of those probabilities add up to 1. So when it's only 2 situations, if I have 1, I can automatically find the other one just by subtracting from an overall value of 1. Now, if you don't really like this, then you can absolutely manually calculate the probability of red-green, red-yellow, green-red, green-yellow, yellow-red, and yellow-green and add them all together, but you still get 13 over 18. So give that a shot and see if you can do that. All right, next up we have conditional probability. Conditional probability is a little bit different, a little bit challenging. Now, there is a really nice formula that we should use for this. In order to get conditional probability, we need to realize that, well, first off, we should probably think about what this means. This is a probability that the second is red given that the first is y. So if it's given that the first is y, what's the probability that the second is red? Now here's the thing, it's not as simple as 4/9 times 2/8 because that's the probability, excuse me, that's the probability of picking a yellow first and a red second. This vertical bar there, that means given. So it's given that the first is yellow. So if it's given that the first is yellow, well, how much is left? Well, that makes it so that there are 24 possibilities. Oh, sorry, 32, right? Because if it's given that it's yellow, we could have yellow, 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 yellow. And if we want to get a second red, we could have red, 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 red. So that's 8 possibilities out of 32 possible outcomes, because we could also have, for all of these, don't forget, we could have 8 possible colors drawn. So if there's 8, 8, 8, 8, that's 32, which leaves a 1 in 4 probability. Now again, that sort of approach isn't very good. It's a little bit better if we use a formula. So if we have the probability of event A given B, that's the same as the probability of A and B over probability of B. So what we can do is we can say that the probability of the second red given the first is yellow, that equals the same as the probability of the second being red and the first being yellow. And we're going to divide this by the probability that the first is yellow. So it's a nice formula. It's probability of A and B over the probability of B. So what is the probability of second red and first yellow? Well, don't forget, in order to calculate that, if we have the second red and the first yellow, that's where we actually do multiply. So the probability that the second is red is 2/8. We multiply that by the probability that the first is yellow, which is 4/9. And then we divide that, because this fraction bar means divide, we divide that by the probability that the first is yellow. Well, the probability that the first is yellow is 4/9. So if we multiply this, we actually get 1/9. And when we divide by a fraction, it's the same as multiplying by a reciprocal. So we actually end up getting 1/4. This is the key formula. So again, if you have the probability of A given B, that's the same as the probability of A and B divided by the probability of B. So figure out what you have, and here we did some simple calculations there, and then just do some simple division. It's really nice. It's a lot better than trying to figure out, ooh, what's what. Okay, here, it's a weird question. I personally am not a fan of this question. It's the probability that we have the first yellow given that the second is green. So there's a little bit of time traveling going on here. So if I just highlight that, given that the second's green, what's the probability that we get a yellow? Now for this one, I'm going to stick right to that formula. So again, this is going to equal the probability that the first is yellow and the second is green divided by the probability that the second is green. So the probability that the first is yellow and the second is green, well, that's just 4/9 times 3/8. And we're going to divide that by the probability that the second is green. Now the probability that the second is green is going to be 3/8. That's the probability that the second is green if we know that green wasn't already picked. If green was picked, in this situation, we know that probability is less than 3/8. It's 2/8. So we're going to keep it here because we know we're looking for the probability that the first is yellow. So if I do this multiplication, I get 12 over 72 times the reciprocal of this, which is 8 over 3. And doing some multiplication and division, this is actually 1/6 times 8/3. So if I cancel out a 2 from both of these, I actually get 4/9. So you can see if we use this formula, it's a lot nicer than trying to figure out what's going on and where all these sample spaces are. Right? And same deal with this. If we have the probability that we want to get the probability that we pick a first ball to be red given that we pick a second ball to be yellow, that's going to be the probability that the first is red and the second is yellow divided by the probability that the second is yellow. So if I highlight that situation where we have a red, yellow, what's the probability that I have red first and yellow second? And that's 2/9 times 4/8. And I'm going to divide this by the probability that the second is yellow. So I'm going to divide this by 4/8. So I'm actually not going to reduce this because 2/9 times 4/8, and then if I multiply by the reciprocal of this 4/8, I actually get this to be 1. So that cancels out, and I'm left with just 2/9. So what's the probability that I get a first red given that my second is yellow? It's 2 out of 9. Here, what's the probability that I get at least one red? Well, this is going to be a whole big mess. So I want to find the probability of green and red. I want to find the probability of yellow and red. And I want to find the probability of red and red. Now the probability of green and red, don't forget, that's the same thing as red-green and green-red. So red-green is 2/9 times 3/8, and I'm going to add that to green-red, which is 3/8 times, 3/9, because it's the first one, times 2/8. I'm going to add that to the probability of yellow-red, which is 4/9 times 2/8. I'm going to add that to the probability of red-yellow, which is 2/9 times 4/8. And I'm going to add this to the probability of red-red, which is 2/9 times 1/8. Now, this is a situation for red-red. So don't worry about adding that twice because that's just there. So if I add this, I get 6 over 72 plus 6 over 72 plus 8 over 72 plus 8 over 72 plus 2 over 72. This adds up to 30 over 72, which I can reduce to 5 over 12. So what's the probability I get at least one red? It's a 5 out of 12 probability. And finally, what's the probability that I get a red and an orange? Well, there is no orange. So there's a bunch of reds that I can get, but I need a red and an orange. So what's the probability I get a red and an orange? It's 0. So make sure that you review the formula for conditional probability. Make sure that you feel comfortable making a probability tree and multiplying fractions.